Hello and welcome to my video on volume. So here we're taking a look at the volume of a bunch of different three-dimensional shapes. We have the formulas here as they are shown on the Math 10C formula sheet. And these questions that we're about to do are not an exhaustive list, they're just some examples of what you could see. The first couple are really easy because we're basically just using the formulas. And then composite shapes down here, just keep in mind you add the two different volumes together or you subtract the volumes together. So we'll talk about those in a bit. Okay, let's start at the beginning here with a simple one, the right prism. Any right prism actually holds true that it is the base times the height, and actually the cylinder counts as a right prism as well. It's just the base times the height. So what is the base? Here is the base of this shape. Here is the base of this shape. Whatever the odd shape out is would be our base. And if it's a cylinder, it actually holds true to the same sort of standards. Same sort of rule. So the base is the circle part. And as we talked about in the last video, circle is pi r squared. Okay, so with this base, so this we're talking about volume. So this base is length times width. Okay, this base, we're not done with the volume formula by the way. This base is pi r squared. And this base is base times height divided by 2. And when I say base here, I'm talking about the triangle base. Maybe we'll use a lowercase. Okay, now, like I said before, so they're all base times height. Okay, but what I just wrote was the base. Now I'm timesing by the height. Okay, so the first one is really easy. Length times width times height. I mean, it's as easy as it comes. So let's go ahead and calculate this. 4 times 7 times 13 is going to be the volume for this first shape. So it is 364 meters cubed. Okay, this volume for the cylinder, I mean, we didn't put any numbers down, so we can just leave it. But the volume for this next one would be bracket 3 times 4 divided by 2 bracket times the height, or in this case kind of length, which is 8, so 48. Okay, and if we were to kind of just follow the same sort of rules, we could find this value as well. If we knew the radius to be, I don't know, 2, and the length to be, let's say, 10, well, then we can figure this out. So then we would get pi r squared times h, and I wanted to put bracket there, but that's okay. Well, let's do it anyway. Times 10. Brackets aren't necessary here, but I'm doing them anyway. So 125.7 centimeters cubed. I'm going to pretend like I wrote centimeters before. Alright, so those are all different right prisms. I mean, it's a rectangular prism, it's a right prism, it's a cylinder, so all of those are now done. Now we can talk about a cone. A cone, you basically just have to memorize the formula. There's no, well, okay, there's a one good way. The sphere, sorry, you just have to memorize the formula. So the formula for a sphere is simply 4/3 pi r cubed. There is a reason for it. It has to do with calculus, but we're not going to get into it in this video or in this course. And for a cone, it makes a little bit of sense, more so when you think about a pyramid. Here we've got a pyramid, 3 different pyramids that you can see if you fold them up together, the blue one, the green one, and the red one actually form a cube or a rectangular prism. So the volume of a pyramid is 1/3 of the volume of its regular old prism. Now that holds true for a cone as well, except that instead of being a prism, we're talking cylinder, which is a special type of prism. But it is basically still the same thing. So basically the rule is 1/3 the volume. Okay, so a cylinder, we already talked about just in the middle there, top middle. This is going to be the same rule, except that it's 1/3. So everything is the same. So we have the pi r squared, and we have the h, right? But what we've changed is we're doing 1/3 of that. So that's the new part that's happening. So in this question, what does that actually get us? It'll be pi r, which is 3, squared, times the h, which is 4, and then divided by 3. So the 5 is the slant height, so we're not using that value when we're talking about volume. Just keep that in mind. We use it when we're talking about surface area. So 7.7 centimeters cubed. Okay, so now let's, so we finished that one. Actually, let's talk about or find the value for the sphere as well. So 4/3 times pi times r and then cubed. So 7,238. And then usually the question should tell you how many decimals to have, but I'm just kind of deciding arbitrarily how many decimals. All right, so hopefully that helped a little bit. These are basic volumes, basic shapes. Now let's take a look at 2 more complicated ones. So here they are. Go ahead and try to find the volume of these composite shapes. Okay, hopefully you paused the video and you tried them out yourself. Now you can press play and compare. Okay, so this first one has 2 different volumes. It has the volume of the cylinder, right? So that's going to be the first part, cylinder, okay, which is pi r squared times h, plus we're going to have the volume of the rectangular prism. Okay, which is length times width times height. Okay, so to be able to find the actual answers for this, it would be pi times r, which is 1, times h, which is 8 minus 2, so 6. Why am I saying 8 minus 2? Well, this 8 is the whole height, but we only want the height of the cylinder, so we have to subtract this part. I looked over here and I saw that this is 2, which means this is 6. So anyways, should be 1 squared, I guess, but that doesn't really make a difference, 1 squared. And then plus length times width times height, so 2 times 4 times 4. And so we get a volume of 50.8. Okay, so composite shapes, you basically just add up the different shapes. Here's a different example. If you feel like you understand it now, pause the video, try it out again for yourself, and see if you get the same answer. Okay, so let's compare. We've got the two different shapes. We've got our first one is the pyramid. Okay, and so it's a pyramid. Okay, so we're going to include that shape, that size. So it's 1/3 base times height. Yeah, that's basically all we can do. Okay, and then the big idea here is that we're subtracting, because this white part is not being included, we're subtracting the cone. And you know what, I probably should use green for that, but that's okay. So we're subtracting the cone's volume. So the cone is also 1/3, but it's pi r squared h. Okay, yeah, so let's go ahead and plug all of that stuff in. So it would be 1/3 times the base, which is 7 times 12, times the height, which is 10, minus, and then 1/3 times pi times r, which is 3. Okay, because 6 is the diameter, not the radius. So r squared times the height, which is 10, and we get a volume of 185.8. And I'll pretend like that's meters cubed. It doesn't say meters, but it should have. It should say some sort of units. And just so you know, this is the diameter here. Okay, so yeah, volume is as straightforward as that. You are just looking for the space inside the shape. So in this case we're subtracting, in this case we're adding two different shapes together, and this is just a couple basic examples. I hope this video helps you understand volume a little bit better, and good luck.